Sorry?
Was that your brother?
What?
Your brother used to think it was nice that he wants the t-shirt, right?
Yeah,
Like,
yeah.
He doesn't like it anymore.
Yeah. Oh, sorry. Okay, I think it is recording. I can't minimize. Yeah, whatever. Yes, this should be fine. Oh wait, no, maybe share screen. Do that. Okay, great. So this is just my little introduction to blockchain. My name is Simon Sellström. I am recently, well, I graduated in 2022, but still work in the sort of blockchain space, live here in Oxford. I was part of the Blockchain Society when I was still a student, and I still kind of help out organize and do small talks. So just a brief overview. What is blockchain? What is Bitcoin? What is Ethereum? And some of the challenges. We're not going to talk through all of these things because I want to just keep it quite brief and simple. So let me start with the story. The story, yeah, I hear some voices, but it's fine. So Yap Island is an island where people use stones, big stones, to transfer value. So here's just a brief video.
The concept of distributed ledgers has been around for hundreds of years. To understand the basics of blockchain, it's important to understand how distributed ledgers work. A distributed ledger is a collection of data with no central administrator that has been agreed upon by consensus. To understand more details, let's take a trip way back into 500 AD on the island of Yap.
The Yapese people used a very unique form of currency, the rye stone. Each of these stones weighed around 200 kilos, making them difficult to move. To exchange them as money for goods or services, they divided the stones into sections, and then they would announce to every adult on the island who owned what part of each stone. Each adult had to keep a mental ledger of ownership. Every time any Yapese conducted a trade, an announcement was made to the entire tribe. Each member of the tribe would then update their mental ledger. In today's description, this would be called a distributed ledger. All rye stone ownership was known to everyone, and that knowledge was updated whenever a transaction was made. So why didn't just one member of the tribe keep track of the rye stones? What if that main record keeper was sick, unable to do their job, or was found to be dishonest? If the only copy of the ledger was changed by any means, wealth would be lost or gained unfairly. The Yapese knew their distributed ledger system safeguarded it from tampering, since all the Yapese knew who owned what. It would be very difficult to fool everyone on the island. Even if one tribe member moved away, the tribe still had multiple copies of their mental ledger. In this regard, the ledger was fault-tolerant and could not be easily changed, corrupted, or lost. The tribe also decided that stones didn't have to be on the island to hold value. One day, a stone fell into the ocean, and the Yapese decided that this stone, even though it could not be seen, still held value and could still be traded. This system of consensus by the majority of the adults on the island, with no central administrator, is one of the first examples of distributed ledger.
Okay, great. So this was just, so for those of you coming in, very much welcome. What we just saw in the video was that we had, this was another way of transferring value and keeping track of who owned what. And it was very much in a distributed manner. One of the things I'd like to highlight here are two of the key properties of these systems. Number one is transparent. And so everyone can actually check. It's like a Google Sheet that everyone has view access to. Number two, it is distributed, meaning that you don't have someone who is a trusted record keeper. All these banks that we have around, we essentially trust them to be record keepers. If you actually talk to people who work in the space, they will reluctantly reveal, or maybe not, that, well, sometimes we mess up. We like money comes in and we just lose track of stuff. to perhaps your surprise, but they will never want to admit those things to the public. Now, so that's why I say they maintain a record of who owns what. Each one has their own kind of copy. Now, how is this related to Bitcoin? Bitcoin is the famous, or first, I would say, blockchain and cryptocurrency. So, right, two key elements. Number one, the database. It's kind of like a Google Sheet that you only add data to, but do not remove. Well, you need to special permissions to add data. Number two, you have a certain rule set that specify who can update this database. And more specifically, you need to have the right cryptographic private key. And so when I say that I own a Bitcoin and I have a wallet, this does not mean that I have like a Bitcoin that sits in my device. It means that I hold the right to sort of make an order. I can tell the Bitcoin network, I want this Bitcoin, which I have the control over using my cryptographic key. I want this to be sent to my dear friend, Nishan. And then the second part of this rule set that I'm talking about are the maintenance of this network, because why would anyone maintain this network? You need an incentive system, and this is where Bitcoin, the cryptocurrency, comes in. So keep in mind there's blockchain, the database, and then there's also a cryptocurrency typically associated with this blockchain, and that is some people describe it as a necessary evil, but that's on the high level. So we have these tokens to incentivize the maintainers of this database. In the case of Bitcoin, it's mining. We don't have to go into detail of what that is really, but it takes a lot of energy and it's a way to secure the network. So BTC is the crypto asset that incentivizes maintenance of the Bitcoin blockchain. And confusingly, we refer to both the network itself and the cryptocurrency as Bitcoin, or BTC would be the crypto asset. So as before, it is a distributed database, a so-called ledger of transactions, and they follow the rules which one could refer to as the consensus protocol. You have to have some kind of mechanism to describe what is the truth. So there's a lot of talk about trust. I think it's worth mentioning that in the case of a bank, we are trusting that the bank keeps track of how much money I have in the bank account. In this crypto space, we talk a lot about trustlessness, because in this case, you trust instead this rule set that is encoded and is distributed among all the maintainers. So we say it's trustless, but in fact, more accurately, we trust the code instead. We don't trust the person. So now, before I'm handing things off to our dear guest here, I'm just going to talk about why blockchain, like what are the use cases? Is this just speculate and transfer illicit funds, or maybe there's something else? I'm going to do my best to talk about some that I think could be actually true use cases. So, problem. Bank asks me, hey, Simon, show me your ID and answer me, where did you get your money from? I show them my passport and I produce a few PDFs or receipts and I say, hey, here's where I got my money from. And they say, okay, cool. Or maybe they ask for more documents. The fact is that this costs a lot of money. Like we're talking about millions and millions for banks. And it is not that good, to be honest, because you can't really know where a certain pile of cash comes from. Not really. I can say where it comes from, but you can't really trace it. In the case of blockchain, you have generally full traceability of the full history of a given crypto asset. So I can see from the point at which it was mined or created, as part of the incentivization process, I can see the full history, which hands it has through. So I believe that with a little bit more technological development, using especially something called zero-knowledge proofs, you would be able to get the benefits of privacy, so not everyone can see literally everything, while still maintaining this traceability property, where you can see the full history of a given cash amount. So that's the first. So that would hopefully reduce the cost of compliance and remove issues with money laundering and things like that. Second, well, what is the problem? Well, in this case, Francesca Gino of Harvard, the former Stanford president, and the former dean of the social science faculty of Tilburg were all people who committed blatant research fraud by tampering or manipulating data that they used for their papers. Now, that's a very complex problem. It's much deeper than this. But one thing that you can do with a blockchain is you can upload a hash of any data, which means that you can prove that you indeed, at a certain point in time, had this data. So assuming you still have it, you're at least able to say that this was collected at this point in time, and I haven't changed that. This was the raw kind of primary data. This though only works if I have changed incentives. So if I lie in the beginning, this doesn't solve it. But if at one point in time I do my research, I commit, I show the data, and then I'm able to prove my innocence. Lastly, we're going to talk a little bit about games. So there's a game called Archlord that actually my grandfather played. Lo and behold. So he played this RPG game that was not super popular. You probably never heard about Archlord, South Korean, but they closed shop. The company didn't want to maintain it. So private service was set up and people started playing it. However, the server went down. The ones they kind of burned down apparently. So all of the characters, everyone who had done, first in the original game, Archlord, build up the character, level up, got items. They lost that, and then on the private server, built up, did the same thing, lost everything. So the solution, or one way that people in the blockchain space propose to get around this, is by having assets on chain, which means that I level up, my character is represented on this distributed network. And so if the front-end company or the game designers decide to shut down, there's a pretty good secure backend essentially, where that another enthusiast can pick up on and say, oh yeah, I'll just get the data from there. This is the level and it's legit, so to speak. We know what it was leveled up or updated. And then so you can bring your character to this new game. But you can not just do that, you can also bring it to another game. So let's say I'm playing World of Warcraft and I want to continue with my kind of warrior level 100 into Diablo. So in this case, with a shared backend, the argument is at least it will be easier to do so. So it's all about interoperability. With that said, this is the slide for more details, which I'm not going to go through today. Stuff like hashing and so on, but we'll share these slides with you so that you can have a look later on. I think you can talk about smart contracts, perhaps. Yeah, you can do the brief on that. So I'll stop there. I just want to say also welcome, and I'll just briefly ask if you could introduce yourself, like name, what you study, and perhaps.
And photography consent.
And sorry?
And if whether they consent to photographs.
Oh, okay, right. Sure. So
OxAI's.
right, the policy. Okay, great. But in that case, I'll just start, Simon, and I consent to photographs. I was at Hartford College and did the MPhil economics. And then I think we can let's go. Should we go from you then, and then go around?
Hey, I'm Nishan. I'm fourth engineering student on the MH program, and I'm from Brasenose.